In the last station, we talked about porosity and permeability and how that affects water's ability to travel through different types of sediment. Now we're going to look at how those principles actually apply underground. In this model, we have some groundwater. It's full up to here. You can probably see the water table line across here. And all this water is being stored in what we call an aquifer. An aquifer is just an area in ground where water is stored. And the water table is the top line of where that water is saturated to. So I have a few different layers of sediment here that are making up our aquifers. The first layer is some sand, and then we have some gravel, a layer of clay, and then another layer of gravel underneath of that again. So on top here, this layer of sand and layer of gravel make up an unconfined aquifer, and that means that nothing is restricting the flow of water through this area. Underneath of there, we have a layer of clay. And this is making up what we would call an aquitard or an aquiclude, and that's an impermeable layer of ground. So like we learned in the last station, impermeable means no water can travel through it. And the example that we used in that station was a piece of pumice, which we don't really find under the ground here, but we do find clay, and we often have granite and other types of impermeable stone. Underneath of that aquitard layer, we have another aquifer made of gravel, but this one is called a confined aquifer, and that's because it's underneath of this aquitard layer here. And there's nowhere around here in our model that you can see where more water actually might be able to get into that aquifer, the confined aquifer. And so what we have there is two different recharge areas. What we mean by recharge is just rain. So if it rains on our model right now as it is, we would be recharging this unconfined aquifer on top. But there would be no way for the water to actually get through our impermeable layer and recharge our confined aquifer on the bottom. And most time, a confined aquifer is recharged elsewhere. It's not totally confined, it's just confined in this area. So if it rained a little bit further away, where the aquifer was no longer confined, the water would travel through the ground to reach our confined aquifer here. So why don't we look at how water would travel through these two types of aquifers and through these couple of different types of sediment? If you remember from our last example, we looked at how water travels through sand and gravel. So let's see if you can predict which aquifers it'll travel more quickly through. This one on top here through the sand, or the one on bottom with the gravel in it. Now we're going to make it rain. So as you can see, the water's traveling much more quickly through the gravel than it is through the sand, just like we talked about in our porosity and permeability station. Now, where I put the food coloring in this little tube is representing a well. And there are two different types of wells in this model. A water table well, which goes into an unconfined aquifer, like this one, and an artesian well, which goes all the way down into our confined aquifer here. Now, if you have an unsealed well and you put in a pollutant, or it rains and there's a pollutant on the ground, it can actually pollute the whole aquifer. So if we were pretending that our food coloring represented a pollutant, you can see that it's going to move all the way through each of our aquifers. I hope you learned a little bit more about groundwater and aquifers from this part of our station.